Hello everyone. So I welcome you again in my lecture. Today we are going to talk about stacks. Stack is one of the very fundamental data structure. It is used in many applications and the tasks that we are doing on the computers are actually accomplished with the help of the stack. So we'll see what the stack is. So in this lecture we are going to talk about the basic concept of a stack. We are going to see that how these stacks are represented as a data structures. We will see how we can implement this stack using different techniques. We will also focus on some application of the stack to have a better understanding, and we'll see that how it can be used in recursive problems. Okay, so let's start. So basically when we say stack is a ordered group of homogeneous items of element. All the elements are of same kind. As you see that you can say when a stack of trays, all the objects are of tray type and they are placed one over the other. Now, the main property of the stack is when you do this kind of arrangement, when you place the item in such a way, then you will observe that the item that you are keeping at the last is actually to be taken first, and we call this as a LIFO. So LIFO stands for last in first out. You may also come across in some books that it's written as philo also, but that is very rarely used. Philo is first in last out, or you can say last in first out, which is the very common term that we use with the stack. So stack is worked on the principle of LIFO. The tray which you are going to keep at the last, at the top, is going to be taken first. Here also you can observe one more thing, that elements are to be added and also the removed from the top of the stack. That means if you want to add something, you are simply looking at the top, and if you want to remove something, you are looking again at the top. So top is something that actually provides you both the operation insertion and deletion. Now this is something that we have to keep in mind when we apply this concept programmatically. So in this concept of a stack, we have a data structure which provides only one endpoint, and from that one endpoint we are going to perform the insertion operation and also the deletion operation. And if we are doing in such a fashion, we are saying that we are actually doing LIFO. We have achieved the LIFO principle. So let's see that how the stack can be used in the computer science. So let's understand the use of a stack in computer science. The very fundamental use of a stack you can visualize when we make a call of any function. So whenever a function is called in any programming language, actually implicitly the stack is working there. So whenever any function is called, the stack is actually implemented, and every call will do the push operation. So push is basically the operation where you are inserting something to the stack, and pop is the operation where you are deleting from the stack. Logically, we assume that a stack will look something like this, where we have uh, one open end which is actually used for inserting something and also for deleting, and we are calling this open end as a top. So whenever any function is called, we are pushing into the stack, and when that function completes its execution, we are actually popping it from the stack. This is how the computer actually uses stack to perform its operation. Now, let's say we have a series of function calls where function A is calling to function B is calling to function C, and function C is calling to function D. So in that case, what will happen? So when you make a call to function A is being pushed into the stack, and then when this function is going to be executed, it is make a call of function B. So function B is going to be pushed here. Now in return, when function B is going to be executed, it makes a call of function C. So function C is going to be pushed. So you will see that whenever any function call is made, it is going to be pushed in the stack. And when that function is completes its execution, it is to be popped from the stack. So initially they all are being pushed because they have been called, and once they have been executed, they will be popped from the stack. So this is how the things are working. Here we can see that the function call in the programming language is actually implemented with the help of the concept of stack. So let us understand why actually the stack is helping us to get this task done. So basically when we use stack, we actually want to ensure that the proper execution of the order of the function can be done. Means whatever the function you have been called, and if they have to maintain some order, then stack will help you to maintain this condition. For example, here we want to call A in call return call to B in return call to C in return call to D. So we want to maintain some kind of order, and this can be maintained with the help of stack. Now let us understand that how actually the things are working. Even if this is not a chaining call, whenever you make a call of a function, it actually uses a stack to get its call done, or to get that things happen. Now how the things are working. So let's say we are having one function A which performs some task. Let's say it takes two parameter of type integer. It will do some work, and then we have a main. When you run your program, it always executes from the main block. Now inside the main, you have some logic to perform any task, and inside that you are calling the function A. So you call function A and you are passing two variable, let's say A and B of type integer. Now when you make a function call, the control has to transfer to this function to get the required task done. Now how the operating system will manage all this thing? So whenever you make a function call, now this is something function one which actually exists in some part of memory. This is a main body which is also having some address of this location where it is executing. So when you are moving from one address to other address and coming back, how this is maintained. So what is happening whenever you are calling a function and using these parameters, one stack is getting formed. So the OS will create an stack, a temporary stack you can say, and it will write the address of this main where the main is executing. So you can just write the address of main, and then it will pass the parameter which is need to be passed to the function. So we'll push the parameter A, parameter B, and then it will pass the address of this function where this function definition has been stored. So you will pass this function A. Now this entire stack is being passed to the operating system. What it will do, so it will just pop the first value, and from the first value it will get the address of that function. So it will reach to this function, and then it will pass this value B and A. It will pop B and A, supplies to this function, and then function will execute. So once this task is finished, it will again pop this value, and it will get the address of the main block, and it returns to the callee function. So this is how the things are actually working. So this is just a rough idea, just to have a feel that how the stack is actually used in this scenario. Even when we do recursive call in the function, again the stack is being used to implement that kind of requirement. So let us first understand what are these push and pop operations, and then we will see more uses of stacks in our real life. The two fundamental operations of the stack is push and pop. Push is a insertion operation. So whenever you want to add anything to the stack, so instead of saying adding an element or inserting an element, the technical term that we use with the stack is a push operation. Similarly, if you want to remove something, if you want to delete something from the stack, instead of using these terms, we call it pop. So these are very technical terms which are used frequently in context of a stack. So push. Now also keep in mind one thing. When you call push, your intention is to add something. So push will contain one parameter, which is the item, which is the data which you want to keep in the stack. Whereas pop does not contain any item, because it will simply return the value which is actually existing at the top. The top, which refers to the top position, it will always point to the top element, because this is something which is based on LIFO. So stack is something last in first out. So every time when you want to insert something, you have to insert at the top position. If you want to delete something, you have to delete from the top position. And when you work in this fashion, you actually make this principle last in first out. Whatever you are inserting last will be popped first. So empty is used to check that the stack is empty or not. So it returns the boolean value. It returns true if the stack is empty, and it returns false if it is not empty. So just keep in mind we are working on LIFO, last in first out. Stack can be implemented either using arrays and linked lists, as I told that it is also a homogeneous collection of elements, but we will make our array to behave in such a way so that it can follow the principle of LIFO. So that means, and when we talk about the array is something which provides you random access. You can access any position, you can insert at any index, you can delete at any index. But if you put some restriction on the array so that it can work on LIFO, so it becomes a stack. Or you can say an array which follows the principle of LIFO is said to be a stack, or linked list which follows the principle of LIFO is said to be a stack. So we'll see that how these things to be implemented.